Hello, in this video we're going to have a look at another example of hypothesis testing. This time we're going to have an example that has two tails. Right, what have we got? We've got Andy playing tennis. The probability that one of his serves is in is 60%, so his first serve probability 60%. In the first example he's serving 20 times. I'm not going to bother with part A, that's just some binomial which you can have a look at if you want to. Part B is the hypothesis test part that I want to have a look at. So Andy's coach thinks that the probability of Andy getting his first serve in has changed, and this time he's serving 50 times, so we've got an N of 50, and 35 are in court. A question says, stating your hypothesis clearly, test the coach's claim that at 10% significance level, is he correct? And there's a really important word here, and that is this word changed. So previously they thought that his probability of success was 60%, so I've got P equals 0.6. We've got 50 serves, so N is going to be 50, and we've got 35 of them in, so X is going to be 35, and we've got a 10% significance level is 10%. But what we've been told is we haven't been told to test whether his probability has gone up, in which case we'd be testing P greater than 0.6, and we just have a single tail. They haven't suggested that the probability he's actually got worse, and his probability is now less than 0.6. Again, we'd still have a single tail. If it's less than 0.6, we'd be testing P less than 0.6. They've actually asked us to test that his probability has changed. That means we need to consider that it's got smaller as well as got bigger. So let's have a look and see how we can do that. So first things first, we want to state our null hypothesis. So under null hypothesis, we're going to go back with the assumption that his probability of success hasn't changed. So under H0, P is equal to 0.6. X, which is going to be my number of first serves in, and under H0, X is going to follow a binomial distribution. We've got 50 tests, it's going to serve it 50 times, and we're assuming that the probability of success is fixed, it's constant at 0.6, so 0.6. So that's my null hypothesis. My alternative hypothesis, remember I'm not testing that he's got better or he's got worse, I'm testing whether he's changed. So I then need to put in my P is not equal to 0.6. And this means I've got a two-tail test. I'm going to be considering P less than 0.6 and also P greater than 0.6. My significance level of 10%, I'm going to need to split in half for each tail. So I'm going to test my value, which is X is 35. I'm going to test the X probability that X is greater than or equal to 35 with a 5% significance level. And I also need to consider how unusual it would be to get less than or equal to 35, but with that same 5% significance level, so that when I add them together, my test comes up to the 10%. So I've got a two-tail test, and I've got 10%. I want to split that in half for each tail. So 5% for the greater than or equal to 35, and 5% for the less than or equal to 35. The next thing I want to do is I want to have a think about, because I might save myself a little bit of time, which one of these is more likely to be significant. Well, if I'm doing a trial 50 times and I've got P at 0.6, so 50 lots of 0.6, I would expect, well, this is going to be equal to 30. So if his P, probability of success, is 0.6 and he does it 50 times, I would expect his first serve to go in on 30 occasions. We've got an X of 35, so we've got a number that's bigger than our expected value. So chances are, if any of these two are going to be significant, the one I'm most likely to be interested in is this probability that getting 35 or more and seeing whether that's significant. This one's unlikely to be significant. I still need to test it, but I'm going to start here because if I'm able to reject my hypothesis on this tail, then I'm all good and I haven't got to bother doing this one. So let's have a look. Probability that x is greater than or equal to 35. Well, that's 1 minus the probability that x is less than or equal to 34. Put that into my calculator. So we're on distribution once it's switched on. Distribution, we're going to go down to binomial CD, number 1. Just going to put in a variable. My x value is 34. My number of trials is 50. My probability of success is 0.6. Hit equals, and I've got equal to 1 minus 0.9045. What's that going to be? That's going to be 0.0955, and 0.0955 is greater than, well, that's supposed to be a greater than, 5%, which is my significant level. So this question's a bit nasty. They're going to try and get you to test it at 10% and say 0.955 is less than 10% and I want to reject H0. They're trying to get you to fall into that trap. We've got 2 tails and I'm testing 5% in each tail. 0.0955 is an unusual event, but not that unusual. It would occur just under 10% of times. So it's bigger than my 5% significance level, and I've got insufficient evidence to reject H0. I still need to have a little look at the other option, the other tail, which is probability that x is less than or equal to 35, and see what value I get there. So I'm going to pop that in. If I go back to my x, I'm looking for x is less than or equal to 35. I've still got 50 trials and I've still got a probability of success of 0.6. If I put that in, I've got 0.94. So what that's telling me is 94% of the times I'd actually expect him to get 35 or fewer serves in. So that less than, the smaller tail, definitely not significant. That is way smaller than 5%. Definitely smaller, definitely bigger, sorry, than my 5% significance level in the other tail. So this one's never going to be important. I knew it was going to be this one if either of the two, because I compared it with my expected value of 30. So if either of them were going to be useful, it was going to be this one. But I still need to test both tails just to make sure that they're both outside my 5% significance level. So for that one there, I'd go through, I'd make the same statement, insufficient evidence to reject H0. So I've made my statement in relation to my hypothesis test and my binomial model. In my model, I haven't got enough evidence to suggest H0. I still need that final statement that puts the question back into context. So there is insufficient evidence at 10% significance level to suggest that Andy's first serve percentage has changed. Okay, so the first statement in relation to the model, is there enough evidence or insufficient evidence to reject H0? Insufficient in both cases here. Final statement in the context of the question, insufficient evidence at 10% significance level to suggest that Andy's first serve percentage has changed, and then we pick up all the marks in the question.